Good evening and good morning to our participants, and thank you all for joining us today. My name is Jessica Gordon, and I'm a Climate Policy Fellow with the California-China Climate Institute, and I'll also be the facilitator for today's discussion. The recent Intergovernmental Panel on Climate Change, called by their acronym IPCC, Working Group 2 Report on Impacts, Adaptation, and Vulnerability was released earlier this spring with alarming findings about the progression of climate impacts around the globe. We're delighted to have a panel of issue experts from the IPCC here with us today to share more about the latest climate science. Before we get started, I'd just like to share a few quick housekeeping notes. We are recording this event and it will be available later on CCCI's website. This event is also being simultaneously translated into Mandarin Chinese, so you can use the globe icon at the base of your screen and then select either the English or Chinese channel for your preferred language to listen to. If you'd like to ask a question of one of our panelists during the audience Q&A portion of our event, please type your question into the Q&A function at the bottom of your screen, and we'll try to answer as many questions as we can live. So now I'd like to introduce our distinguished panelists, and then we'll hear remarks from each of them before moving into questions and answers. So first, we have Dr. Eric Chu, who is an assistant professor with the Community and Regional Development Program in the Department of Human Ecology and co-director of the Climate Adaptation Research Center at UC Davis. With a background in city and regional planning, Professor Chu is an internationally recognized expert in climate change policy, urban governance, environmental justice, and international development. Professor Chu's research is place-based and globally comparative and focuses on understanding how local governments, communities, and civil society groups work together to plan for and adapt to the impacts of global climate change. Next, we have Dr. Patrick Gonzalez, Associate Adjunct Professor at UC Berkeley. He's a forest ecologist and climate change scientist. He advances science-based action on human-caused climate change through research on climate change, ecosystems, deforestation, wildfire, and carbon solutions, and assistance to local people and policymakers to protect biodiversity and human well-being. Dr. Gonzalez has conducted field research in Africa, Latin America, and the US, and has published in Science, Proceedings of the National Academy of Sciences, and other journals. Dr. Christy Ebi has been conducting research and practice on the health risks of climate variability and change for 25 years, focusing on understanding sources of vulnerability, estimating current and future health risks of climate change, designing adaptation policies and measures to reduce risks in multi-stressor environments, and estimating the health co-benefits of mitigation policies. She has supported multiple countries in Central America, Europe, Africa, Asia, and the Pacific in assessing their vulnerabilities and implementing adaptation policies and programs. Finally, Dr. Carolyn Enquist is the acting director of the Southwest Climate Adaptation Science Center and is also an employee of the US Geological Survey. Over the past 2 decades, Carolyn has worked for the National Wildlife Federation, the National Park Service, the US Forest Service, the Nature Conservancy, the Wildlife Society, and the US National Phenology Network. She is largely focused on management implications of climate change for biodiversity conservation. So now we'll proceed in the order I've listed. So Dr. Chu, I'll hand it over to you.
Great, thanks Jess. Thanks for the invitation, and it's great to be here. I'm gonna share my slides with the hopes that the material that I'm covering will not overlap too much with what everybody else is planning to talk about. And so what I want to do in the 7 minutes that I have is to give participants here a quick introduction on chapter 6, which is the cities and human settlements chapter in working group 2 of the 6 assessment report. And so just very quickly talking through some of the key impacts, adaptation strategies, and vulnerabilities that cities around the world are currently facing. Clearly, I can't cover every single risk and impact that cities around the world are facing, And so I guess I'll just start off by saying, laying the foundation here by saying that the report itself, actually, we tried very hard to integrate a lot of discussion about cities and urbanization throughout the entire report because of several reasons. One is that it is projected that a majority of the world's population will live in some sort of urban built environment setting in the next 10, 20 years. And also cities around the world concentrate a lot of critically important and expensive infrastructure and assets. And so when we're talking about climate impacts and climate hazards, there's actually a lot of cost involved in terms of adapting and making infrastructure more resilient in these contexts. And that's not even mentioning the amount of people and the potential loss of lives and livelihoods when extreme events happen in cities. I'll spend just a minute or two talking about one particular key risk that we talk about in the chapter, which is urban heat. And this is a map that I've just copied over from the urban fact sheet, which actually appears in the Working Group 1 assessment report, but we build on it in our Working Group 2 approach as well, really showing how cities are actually sites of compounded climate stress. And so if you look at the chart here, the little bubbles, what you'll see is the proportion, the shaded proportion of the circles are the proportion of urban warming that is produced by just the density and the building construction materials and the people in cities. So that just density, that physical proximate kind of people, infrastructure, houses, and buildings actually adds heat on top of what the level of warming that's projected by the many great scientists, climate scientists that work for IPCC. So what you'll see in Asia in particular, the kinds of urban designs, city landscape designs adds actually a good quarter or a third of adds on top of the existing warming that we'll see. And actually really dense cities in South Asia and Middle East, for example, actually the current way that we build cities adds a lot of heat on top of the 1.1, 1.5 degrees that we're already expecting. And so that trend is nationwide. And so I just wanted to highlight some examples to talk about how the reality that climate adds to many stressors and compounds the current development inequalities, in fact, that we find in cities around the world. So this is another thing just to highlight some of those points. Why are cities hotspots? And so I talked about the shape and layout of cities, human activities, and then also construction materials that we use to build cities retain heat. But in our chapter, we also talk a lot about adaptation strategies. And so we talk a lot, and not to build on, maybe not to kind of take away from Dr. Gonzalez and Dr. Ibai and Dr. Enquist's conversations about all these things, but we spend a lot of time talking about how do cities adapt to these risks and impacts. And we spend quite a bit of time actually talking about nature and ecosystems and trees and water as one strategy to try to mitigate the heat in this case that urban form and urban design actually result in cities. So I mentioned nature-based solutions, working with ecosystems and trying to work that into existing building design engineering strategies to try to mitigate and manage the amount of heat, urban heat that appears in cities, using green blue space, putting in agriculture, social safety nets, because we know that cities around the world, in addition to concentrating financially important, economically critical assets and infrastructure, a lot of people here, and a lot of people here have middle to low paying wage jobs, sometimes housing insecure, and rely on a lot of public transportation, public health services, et cetera, et cetera. And so when climate impacts, climate hazards strike, it is often the lower middle class, lower income communities that sort of bear the brunt of those impacts in cities. And so we spend a lot of time talking about social safety nets and designing new institutions, new decision-making arrangements to try to include those voices in the planning, adaptation, vulnerability reduction process. And here's just finally, just a plug to the others who are talking about health and ecosystems. In our cities chapter, we spend quite a bit of time trying to reach and connect to those different spheres of work that everybody else here will talk about. One interesting thing, one thing that we spend quite a bit of time talking about in our chapter is the fact that cities and how cities have developed around the world for the past couple decades have been quite unequal in terms of the benefits of development have really benefited a very small community, very small proportion of people who live in cities. And so we spend quite a bit of time talking about this question of actually who benefits from some of the adaptation strategies that we're currently seeing in cities. And so this is a slide that I pulled from just the general presentations that folks may have seen before. But we look at how cities, we have a lot of evidence that cities around the world are working to build and design and plan for adaptation strategies. Some of them actually yield positive social benefit, some of them not. And so we go in and actually try to figure out, assess sort of to what extent are some of these actions actually benefiting the most disadvantaged. Using that lens, we talk about how cities are actually sites of innovation and sites of experimentation when it comes to climate change action. There's a lot of potential that cities have to mobilize resources, to mobilize finance, to mobilize citizen public interest to work on climate change. And so we sort of look at how cities are sites of where really interesting things can happen. And so the question is, how do we use that? How do we extend that to a larger scale? How do we get different cities aligned and coordinated and cooperative in kind of planning and implementing adaptation strategies that benefit society as a whole? So that is my 7 minutes. Thanks.
There it is. Hi, can you see my screen? Wildfire increasing in the Western US. Species driven extinct in Costa Rica. Tree death in Africa. From Yosemite National Park in California to every corner of the world. Our IPCC assessment found that human-caused climate change has damaged ecosystems and human well-being. So in my 7 minutes, I will briefly summarize the findings of the chapter on terrestrial ecosystems. It's a team effort, 12 authors on our team, including one from California, me, and one from China, Gao Qingyu. And there we all are, the IPCC team at our first meeting in South Africa. Cars, power plants, and deforestation and other human sources pump over 11 billion tons of carbon into the atmosphere every year. But terrestrial vegetation, terrestrial ecosystems, and marine ecosystems can only naturally remove half of that. And it's the other half, of course, that goes into the atmosphere, and that's the fundamental imbalance that causes climate change. You'll see that terrestrial ecosystems occur on each side of the carbon balance. Tropical deforestation emissions and natural removals through forest growth and wetlands. Terrestrial ecosystems have a net removal from the atmosphere so far. So in the rest of the presentation, I'm going to go through observed historical changes and then future projected risks. The examples from the chapter that I'm going to show you have gone through the 2 scientific procedures of detection and attribution, finding a statistically significant change from natural variability, and we've determined the relative importance of potential causal factors and that anthropogenic climate change is a dominant factor. Climate change has caused 2 species extinctions, including the golden toad from cloud forest in Costa Rica, where climate change has lifted the cloud deck and allowed the chytrid fungus to infect the amphibians. Climate change has also caused the extinction of the bramble K. milomis through inundation of its last island in the Torres Strait. Aside from complete extinction from the Earth, climate change has caused over 400 species extirpations. Those are local disappearances, including a 40% loss of bird species in the Mojave Desert, California, last century. Climate change intensifies the heat that drives wildfire and has lengthened fire season on 1/4 of global vegetated area up to 2 months. And you see a great lengthening in the Western US, including the area of this astounding fire tornado 2 years ago on the east edge of Tahoe National Forest. Wildfire is a natural necessary component of many forest and woodland ecosystems, but excessive fire, of course, damages ecosystems and kills people. We found that climate change has increased wildfire above natural levels in at least one region of the world, North America, where in the Western US, climate change doubled the area burned by wildfire over natural levels since 1984, including the rim fire here in Yosemite. This map shows the global picture. The red dots indicate regions of detection and attribution in the Western United States. The orange dots signify regions of detection of an increase in wildfire burned area, and the yellow dots indicate areas where other factors, including tropical deforestation, agricultural expansion, and peat draining, exert a greater influence than anthropogenic climate change. Wildfire has increased in many regions, but intentional human burning can overwhelm the impact of climate change. Climate change has also increased tree death, doubling tree mortality across the Western US since 1955. Through the most intense drought since the 1500s, and increased wildfire and increased bark beetle infestations. Climate change has also increased tree death in the West African Sahel, killing up to 1 out of every 5 adult trees and causing the local disappearance of 1 out of every 3 tree species in the West African Sahel. Those 2 cases were cases of detection and attribution of tree mortality. Published research has found many other cases of drought-induced tree mortality that have been detected, but not yet attributed to climate change, including many, of course, many cases in North America. We see many cases also in China. So this is a potential research gap. Climate change has caused the shifts of major vegetation zones upslope or towards the equator or towards the poles. And that includes a biome shift of subalpine forest into formerly treeless meadows in Yosemite National Park. And the combination of climate change and active deforestation for timber and agriculture has caused the Amazon to go from being a net sink to a net emitter of carbon in the past decade. Okay, projected risks. If climate change continues, if we don't cut our carbon emissions, climate change at 4 degrees Celsius above pre-industrial could put 4 to 39% of plant and animal species at risk of extinction. And this is 4 times the number of extinctions that have been caused in the past 12,000 years. But limiting heating to 2 degrees Celsius decreases the extinction risk to half of that. Climate change at 4 degrees Celsius could increase the area burned by wildfire by 50 to 70%, including here the giant sequoias in the Sierra Nevada, California, and also areas in China and around the world, as you see in the map in the upper right. Zooming in on California, University of California researchers have projected up to a tripling of fire frequencies at the highest emissions. It's 4 degrees Celsius. But if we cut emissions, we can actually limit the increase in fire to slightly what it is today, above what it is today. In Kanha National Park in India and across tropical woodlands, the combination of climate change and land use change increases the risks of these biome shifts. And the red areas indicate half of terrestrial land area at a high risk of biome shifts under the highest emissions scenario. Continued climate change of 4 degrees Celsius could cause a tipping point, thawing extensive areas of Arctic permafrost, like here in Noatak National Preserve, a national park in Alaska, USA. Getting towards the end here, we identified 5 key risks in terrestrial and freshwater ecosystems. And you see the gray bar, you see the horizontal axis is the level of temperature, global temperature increase above the pre-industrial level. And of course, the darker the color, the higher the risk. And the gray bar is where we are right now, 1.1 degrees. And you see that we're in the yellow for all 5 of the risks, but very soon, if we exceed 2 degrees Celsius, could go into very severe risks in each of these 5 areas. So in conclusion, in summary, our IPCC report shows that human-caused climate change has driven 2 animal species to extinction, increased the area burned by wildfire up to double natural levels in North America, increased tree death up to 20%, contributed to carbon loss from rainforests and permafrost, and shifted major vegetation zones around the world. But in conclusion, the fundamental solution, of course, to avoiding the most drastic consequences of climate change is cutting the carbon pollution that causes climate change. And IPCC analyses show that we can meet the Paris Agreement, the Working Group 3, and limit the temperature increase to 1.5 to 2 degrees with concerted global action. The challenge is substantial, but recent progress shows that this is possible. In California, we have already cut greenhouse gas emissions to below 1990 levels. From 2000 to 2019, population increased 17%, yet we cut emissions 11%. Through efficiency improvements, emissions per capita were cut 24%, and we cut emissions per dollar of economic activity by 45% through public transit, through renewable energy, and other forms of sustainable action. More of that, and we can stop climate change. Thank you very much.
Thank you very much for your interest in the IPCC report. And we're delighted to provide some highlights of a very long and very dense report. I'm going to talk about how climate changes health. The figure on the right has been used from IPCC reports since, about a decade ago. When we think about the future, we talk about risk, where risk is probability times consequence. When you decompose risk, it's composed of 3 major factors: the hazards created by a changing climate, the human and natural systems exposed to those hazards, and the underlying vulnerabilities. In human health, those vulnerabilities include susceptibility, and the capacity to manage. And this informs all of our presentations, that when we talk about climate change, we also need to talk about who is exposed, we need to talk about the most vulnerable, and we need to talk about how we can manage. The figure on the left is one of many figures showing the wide range of health outcomes associated with our changing climate. As pointed out by the figure on the right, changes in our climate and rising carbon dioxide concentrations interact with a wide range of other factors that influence the exposure pathways that are typically studied in health. The examples of health outcomes are a short list of all of the health outcomes of concern. And you can see that short list is very long indeed. This is a slide that has too many words on it, but there are not good ways to summarize the assessment in Chapter 7 on human health. We looked at observed impacts, and you can see that there are high confidence statements and some very high confidence statements about how, as Dr. Gonzalez just spoke about, there's been detection and attribution, and we know that climate change is adversely affecting injuries, illnesses, and deaths. The major categories are listed in the lighter blue, and you can see everything from extreme heat events through mental health challenges, and also noting that our health services, our healthcare infrastructure is being disrupted by extreme weather and climate events, such as floods. Some examples, this is from the US on billion-dollar disasters. And my apologies, I am sharing one of two presentations I gave today, and it is the wrong presentation. So let me start with the presentation and catch up because it's got some similar slides in it. And I shared these slides and didn't notice that I've got a couple of them on my desktop. So give me a moment and I will fix that. Chapter 7, I talked about that figure. Here's the observed impacts. In this case, I put the areas we looked at, the climate sensitive health outcomes we looked at in red. When you look at one of the figures in the summary for policymakers, it shows in different regions of the world the impacts on human health and well-being. And you can see that there are negative impacts in Asia for infectious diseases, heat, malnutrition, mental health, and displacement. There are similar kinds of challenges in North America. Not the same magnitude in all places, but similar kinds of challenges. We also assessed all the projected risks. Again, too many words on the slide, but it does give you a sense of where there are publications that we could assess. Most of the
apologies, Dr. I for your to interrupt, but your slides are not up.
I'm sharing them. So the share didn't work?
No.
All right, let's try the share for a third time.
Thank you.
Can you see them now?
Yes, we see them.
Okay.
Thank you.
So these are the slides on observed impacts. Here's the figure that I mentioned in the summary for policymakers, where the negative means that there are negative consequences, with similar consequences for the different categories in human health and well-being for Asia and for North America. Projections. Most of the projections in the health sector are for heat waves and for a variety of vector-borne diseases, with the main focus on dengue and on malaria, although there's also projections for a couple other vector-borne diseases. Doesn't mean that these are the most important, but there's where the research has been conducted. Undoubtedly, the biggest health risks of a changing climate is going to be on undernutrition. Similar to what you just saw for health, there's also the synthesis figures that have been used for the last couple of decades by the IPCC. And you can see the burning embers, as we call them, for heat, ozone, malaria, and dengue. What we also did in health is we looked at 3 scenarios of adaptation. So within each set on the left is a figure that shows limited adaptation. The one in the middle where we continue on our current trends. We try to make progress, but it's slower than we need it to be. And the figure on the right is a world aiming to sustainable development. And you can see when you look at these figures, two things jump out at you. The first is how important it is to mitigate. That the more we mitigate, the more we reduce the severity of the risks. Equally important is we have to adapt. We have to increase the climate resilience of our health systems. There are, just as with the observed impacts and the projected risks, a long list of effective adaptation options that are synthesized on this slide. The core element of what needs to be done is to strengthen the resilience of our health systems. As noted at the bottom, a major constraint is limited investment. When you look at the adaptation funds under the United Nations Framework Convention on Climate Change, less than 0.5% of those funds are going to health. So although we know that people are suffering and dying from climate change, there are not matching investments to ensure that we do increase the resilience of our health systems to protect and promote human health and well-being. Another critical area covered in the chapter are the health co-benefits of mitigation policies. And when we look at mitigation policies, there's policies, for example, to reduce emissions from point sources, like coal-fired power plants. Worldwide, exposure to air pollution, some of which does come from coal-fired power plants, leads to about 7 million excess deaths per year. A second major source of mitigation policy is to reduce the number of internal combustion engines. And one can not only reduce the number of vehicles on the road, but one can also increase active transportation, that is walking and biking. And a third major category is changing diets so that people only eat as much red meat as their doctor recommends. Within Working Group 3, you'll see assessments of these mitigation policies and their potential for reducing greenhouse gas emissions to achieve the Paris Agreement. In our chapter, we looked at the health benefits of these mitigation policies, and it's possible to count up the number of avoided premature deaths from exposure to air pollution, the number of avoided hospitalizations, according to these three categories. And when you add these up and take the economic value of the health benefits is of the same order of magnitude or larger than the cost of implementing mitigation. We should be mitigating for our health. And so we do hope over time that there'll be companion statements to the cost of mitigation, to the real value we see for human health and well-being. With that, thank you for listening. Apologies for the slide problem, and I look forward to the questions.
All right, hopefully you can see my slides okay. I want to thank the Berkeley Law Center, the CCI initiative for the invitation. I was with chapter 14, the North America chapter. So what I'll be talking about this evening is I'll be reinforcing many of the messages from the previous speakers, but I will be doing it at a slightly different scale. While I'll come down to North America, the Southwest, and California. So my first two slides are more of an overview of the impacts that we continue to see and expect to increase in the future. As we've heard from our speakers, it's this extreme heat, aridity, size and severity of wildfires, changes the timing and amount of precipitation and snowpack. And even as we sit here today, we're only at 38% of what would be normal at this time of the year in California for our snowpack. Of course, this portends yet another potentially dangerous wildfire season. So in short, hotter droughts, loss of this water storage will reduce some of these flows and access to water availability. And then, of course, as the population has been growing, and when there's increased demands through irrigated agriculture, this will continue to place high demands on our water resources in the Southwest and California. Of course, we've been talking a long time about sea level rise, marine heat waves, changes in ocean chemistry, and the consequences of those things. And what we're seeing is that is continuing, projected to continue even more, and really increasing the risk of flooding, erosion, and more recently, this post-fire debris flow due to extreme precipitation events. And a lot of these extreme precipitation events in California and the Southwest are delivered through what are known as atmospheric rivers, or ARs. And so effectively, we're getting closer to this tipping point, this threshold, where we're going to be seeing, as Patrick was pointing out in some of his graphs, we're getting closer to that point where we'll potentially see irreversible changes to ecosystems, their services, damages to natural and human-made infrastructure, housing. Of course, all of this puts stress on our economic sectors, disrupts livelihoods, recreation, safety, and conservation of our cultural heritage, which is also very important. And as we just heard from Dr. Eby, certainly all of this comes together, and we're seeing this in our region, this increased risk to mental health, physical health, particularly for those populations that are marginalized and on the front lines of some of these impacts. So what I just, again, highlighted was just stuff that we've been seeing. It's ongoing, projecting to continue. So some of the key messages coming out of our chapter this time around for the IPCC, the AR6 report, is that climate risks are appearing faster and becoming more severe and more difficult to manage, especially when a lot of them come at once and act synergistically with one another. As we've been hearing, poverty and inequalities among our populations are effectively climate threat multipliers, then affecting humans and the health of their species and ecosystems. And we've also experienced, I think everyone is aware, a lot of misinformation about climate science. And this, of course, has sowed some of these uncertainties, polarized public perceptions. It has done that for a long time. But effectively, we now need to recognize that this has impeded the recognition of risk and urgency and delayed this climate action that we need now, as the other speakers have pointed out. And what the figure here shows is in the darker colors where adults think that climate is getting warmer. They have that awareness, and then you can kind of see the gradient through different parts of North America in terms of their belief systems relative to climate change. And it's not surprising to see these patterns, but we were able to map them and start to really kind of dig into the emergent literature on this problem of misinformation. All of this contributes to a narrowing time window to reach effective climate resilience. So a big part of the working group 2 for the full report, but also for our chapter, and this is where I kind of dug into a little bit more as an author, was kind of thinking more about adaptation approaches. Now, awareness of the need for adaptation has certainly increased. And especially we see a lot of this in the water-related hazards sector. But what we really need now is more of this coordination and integration of efforts across sectors, and also to do that through equitable policy and finance focused on modifying land use impacts, consumption patterns, economic activities, and it has been pointed out in several of the previous talks, nature-based solutions. What we then think is that moving from this kind of gradual and incremental adaptation approach, if we move into something that we think is more transformational, or we can make more transformational, bring it to scale and address it over the long term, this could actually help us address these rapidly escalating impacts and buy us a little bit more time to also do the really critical work that we need to do on the mitigation front. And so, as other speakers have said, we need kind of the co-benefits of adaptation and mitigation to really get to where we need to go. So really, in sum, what we're looking for is this near and long-term adaptation planning. We need more implementation at scale, coordination across sectors and jurisdictions, and all of this comes together to support equitable and effective climate solutions. And we believe that that will certainly help us get to this more climate resilient future. And I have to say that California cities, as pointed out by Dr. Chu, and certain states have really been leading the way on the adaptation front. And California, not surprisingly, is one of those states that is really making great strides. However, this slide points out that adaptation cannot prevent all losses and damages, even with effective adaptation before reaching certain limits, hard limits and soft limits. Now, this graphic is very complicated, but the takeaway really is that if we can accelerate our options, do the co-benefits with mitigation, and take advantage of some new opportunities that some of the previous speakers have been speaking about, disaster-proofing energy plants and critical infrastructure to ensure market resilience, using a diverse energy portfolio, strengthening our healthcare systems, we've got to really beat that drum, and again, investing in nature-based solutions. So that's basically what this graphic is showing. Of course, you can find it in the report, but we just have to recognize that adaptation is just not going to do it alone. And there are, top limits. The soft, hard limits are being, the extinctions that Patrick spoke about, whereas soft limits sometimes can be addressed through policies, changing hearts and minds, et cetera, and individual households to full-scale government and cross-governments, so multilateral agreements, particularly in North America, to reduce kind of those barriers to doing effective adaptation. And back to the nature-based solutions, we've estimated that effective conservation of 30 to 50% of land, freshwater systems, and oceans will help ensure that we can work towards safeguarding nature, so that at the same time, we can secure people's livelihoods, well-being, increase their access to healthy food, high quality water, etc. So as I had mentioned, we have done, there's lots of great examples of adaptation around the country and around the Southwest and in California. And they have been cross-sectoral. This is another graphic that appears in our report, in our chapter 14, North America chapter. Obviously, you can't read the fine print, but basically what we see is that we have a lot of options, and we can build in a deliberate way on some of the things that we've been doing for a long time. For example, in forests, we do the thinning, we do the burning, and then when I say the burning, with thin forests, thin vegetation burn, that would be a prescribed burn. Some of the intentional uses of fire, what we'd call the good fire, because as Patrick has pointed out, certainly some of our ecosystems need that fire to regenerate. What they don't need is the high severity fire that can lead to damaged forests, and sometimes forests or vegetation types that don't regenerate, and they actually transform into something else. Ecosystem restoration, intentional climate-informed ecosystem restoration is part of that process. And together these can enhance biodiversity and some of the other services that ecosystems provide. Integrated watershed management in the water resources sector is also really critical for protecting biodiversity, increasing water quality, quantity, and really importantly, reducing soil erosion. Again, after those extreme events, we need to keep those soils intact. Those soils take tens of thousands of years to build. And if you don't have the soil in place, you're not going to hold the water, and you're certainly not going to grow any sort of biomass. In the agricultural sector, agroforestry, winter crop cover, some of these types of activities also can increase biodiversity, believe it or not, but also reduce soil erosion as well. So you're starting to see a theme that some of these sectors and some of these actions can really reinforce one another because they're acting together to reduce soil erosion, protect biodiversity, and increase carbon storage. Coastal, again, protecting those coastal habitats, keeping the carbon in place, those kelp forests that are so important off of our California coastline. So again, in cities as well, as we heard from Dr. Chu, there's a number of things, again, that all self-reinforce that we're already doing, but we do them in an intentional way, working together, then we really have increased our opportunity for a successful adaptation. Finally, I wanted to point out that really important need to work with Indigenous peoples throughout North America and the Southwest. Indigenous peoples are actively working in these spaces and are our partners in doing climate adaptation. And our Western practices are oftentimes going to not be enough. We need this Indigenous knowledge, we need local knowledge to come together to help support our adaptation efforts. And this will be critical to reducing climate change risks now into the future. So my final slide is to offer a little bit of hope. And we all know we need a little bit of hope right now after many years of pandemic and numerous extreme events and disasters that we've faced, health crises, etc. And this particular quote comes from Dr. Christy Brigham, and she is the Chief of Research Management and Science at Sequoia Kings Canyon here in California. And she made this quote on a recent podcast called Come Rain or Shine, which is a collaboration between the Southwest CASC and the Southwest Climate Hub with the USDA. And I encourage you to check out that podcast, but I felt that this particular quote really kind of struck home. It really is working together, imagining our future together, where again, our outcomes result in healthy forests, healthy communities, and healthy people all living together. And with that, I want to thank you for your time and look forward to answering any sort of questions. You can find out more also through our websites, our various websites, and our Southwest CASC website on the great projects that we're doing in the Southwest and California to address climate adaptation. Thank you.
Thank you so much for ending us there with some hope. And thank you to all of the panelists for your thoughtful remarks and really comprehensive presentations. I'm so glad that we got to have all this expertise with us today and really were able to better understand the global impacts of climate change. So at this point, I would like to engage our audience in the discussion. So if you have any questions for our experts, we invite you to type it into the Q&A box, which is at the base of your screen. And we'll try to answer as many questions as we can in our next 10 minutes or so that we have left. So I see there's a question in the chat box that really is looking at asking for some examples about effectively implementing adaptation in terrestrial ecosystems at scale. I don't know, Dr. Gonzalez or Dr. Enquist, who would like to take that one.
I can, Carolyn is, adaptation is her area. I can mention a very good case study in chapter 2 of adaptation action is in Joshua Tree National Park, where published research, spatial analyses have identified potential refugia for the species of concern, the Joshua tree in the park. And so because of limited funds and resources, we can't protect everything. And so they actually concentrate conservation on those potential refugia, science-based, protecting them from wildfire, which in that ecosystem is not natural, and focusing invasive species removal there. So the general action is prioritizing potential climate change refuge under climate change. So Carolyn.
Yeah, great. Thanks, Patrick. Yeah, I think, still some of the transformational adaptation, it's still difficult to find some really robust examples. But I think that they are really coming. We've laid the foundation, as Patrick just pointed out with his example, for some of these things to come together, where we work across scales, across governments, and because it's really no one entity that can do it all, right? So we all need to be working together, finding those shared goals, developing those partnerships from the very beginning in some of these things, so that we develop the trust, we develop the vision for the future, that then we can much more readily overcome those barriers, change policies that maybe are barriers too when you have public buy-in. And I feel that, in Sierra, there's some really great Sierra Nevada, there's some really great emergent stories there coming out of the Tahoe Basin, with some great synergies that are happening around Yosemite National Park and Sequoia Kings Canyon, particularly with the extra attention that those two areas have received with the wildfires of the past 2 years. In Sequoia, 20% of these iconic species have been lost. And then also in Southern California, there are some really interesting projects that are starting to come together, bringing together marginalized populations in the LA Basin and linking them up to some of the communities and the mountains that serve as effectively retreats, refugia for humans during those hotter months. And now Southern California is not immune to some of those really extreme heat days. So I'm really optimistic that some of these things will start coming together. If you look in our chapter 14, we do list a number of kind of what I would call a little bit more incremental types of activities going on across sectors. But I think it's going to be bringing a lot of these together, and I feel like there is momentum in that direction.
Jessica, I could add another California-specific example is in the city of San Francisco, actually in Golden Gate National Recreation Area. It's the use of natural shoreline features at Crissy Field and the restoration of the marsh just in back of the beach. So it provides surge capacity for sea level rise and storm surge, and it's a natural climate solution for San Francisco, and we're actually quite fortunate to have a little natural area there that's managed by the National Park Service to implement that adaptation strategy.
Okay, that's a great example. Thanks for sharing that. So we talked a lot about impacts today, and so I was just kind of wanted to also get into a little on what all of you think are really some of these existing legal and policy tools that could be useful in, enabling or supporting this more proactive and coordinated decision making that many of you had mentioned. I don't know if anyone has any examples or ideas from places you work or globally.
I'll take
Dr. Shu, go for it.
because I talked about how cities, and Carolyn as well talked about how cities have really, some cities, a lot of cities have taken the lead in trying to figure out institutionally what climate action, climate adaptation looks like and can look like. And so there's been a lot of developments around building codes, regulations, land use, zoning codes, ordinances, and also recently in terms of risk disclosure for buildings and critical energy infrastructure, energy supply chains, et cetera, just because increasingly it's important to understand specifically what climate impacts are on infrastructure and fundamentally how much it's going to cost. And so yes, so there's a lot of interesting movement from a regulation side, from a policy planning side. There's also softer things like around landscape design. And just to raise another example, China has some interesting examples coming out on sponge cities, for example, kind of working with water, working with flood mitigation infrastructure, and working that into existing landscape, urban design, road design, living with water, basically, for some of those coastal low-lying cities, figuring out creatively and also artistically how to actually create those kinds of urban landscapes that sort of retain the urban function, the cultural social function of cities, retains the economic centrality of some of these cities, but also sort of be able to sensibly and inclusively manage floodwaters in that case. And that comes with a lot of incentives, obviously, from central government in that case, but also zoning, building, land use codes that are in concert, that work to support that sponge city vision.
Great, thank you for sharing that. So all of you have done, extensive research on adaptation. And so I guess I'm curious of kind of what you see as the role of research in supporting better adaptation policy, and kind of what research gaps you see that could be useful for advancing climate policy in California, in China, and other places.
I can start answering that. In the field of meteorology, there's something called research to operations. Even has its own acronym, R2O. And that is something we really need here. We've all talked quite a bit about all the adaptation options that are available. In public health, we have implementation science that moves the research into the field. It doesn't go as quickly as it does in the field of meteorology, of finding ways to change how we approach our research so that it's co-designed with the end user from the beginning, so that you know that when you finish it, that it will be taken up, that there'll be opportunities to look at the lessons learned, the best practices, and to synthesize those so that they can be used in other locations, so that everyone doesn't start from ground zero, that people really start from what we already know and can implement much more quickly and effectively.
That's great. Yeah, I think that's some of that is what I think we're trying to do in California, but as a ongoing process. So we have another question here from the audience asking about future trends of natural carbon sinks, so both terrestrial and ocean sinks, and if anyone can share a little bit about that.
Well, as I pointed out, the observed evidence actually shows, regrettably, that many tropical forest areas, including much of the Amazon, much of Southeast Asia forests, have gone from carbon sinks to carbon emitters. One of the key risks that we identified, as I also pointed out, is a tipping point of thawing of Arctic permafrost, which could release 15 years worth of global carbon emissions. The most effective measure to avoid these catastrophic impacts is to cut the carbon pollution from human activities. And that means cutting global carbon greenhouse gas emissions in half by 2030 and to net zero by 2050. And as I pointed out, recent progress shows that this is possible. The IPCC Working Group 3 has assessed the options, and it is possible to meet the Paris Agreement goals with concerted global action. And I will say that globally, renewable energy has doubled in capacity since 2009, and that we've added the equivalent of over 3,000 coal-fired power plants globally. And in the United States, renewable energy exceeded coal for the first time in 2019, for the first time since the 1800s. And so, Jessica, you've been asking about adaptation. Obviously, our working group was focused on adaptation. The most effective measures is to reduce the cause. And it's great that California and China have established this partnership, and because they're two very key players and leaders, can be leaders in meeting this challenge.
Great. Thank you. So I'm just, for one final question, is for countries and states without resources or capabilities for implementing climate adaptation, is there a role for more capable governments, which I think maybe you're getting to a little at the end of that last question, to help them? I don't know if anyone wants to jump in for that one. Yeah, go for it.
I'll do this quickly. I won't maybe say whether or not, can't comment on whether governments are capable in different contexts, but I can maybe say a little bit about, on the city side, we do have a lot of knowledge sharing, technical sharing, capacity sharing between cities, and not obviously California to elsewhere is one path, but we see a lot of different pathways from developing countries to developed countries, from Europe to North America, et cetera. So it is quite common in that there is a lot of scope to learn, because everybody, all cities are just trying to figure out what this means for them. And they're learning from other cities about what's possible, what are the different options, given the different context factors, how many people, how big the city, what's the landscape, what's the morphology of the city. And so yes, there is a lot of scope in terms of learning. But when it comes to implementation, it really sort of depends on, for cities, it depends on who's there, the citizens, the leaders, and the social community groups that are there to take this on, to actually do something and actually implement and embed climate action into their existing plans and policies, and actually seeing them through. But yes, in terms of knowledge sharing, capacity sharing, that exists. There are a lot of networks out there of all different sorts and types.
Great. Well, I want to thank all of our panelists so much for your great presentations and answering these questions and being with us tonight, and also our audience for joining us. We really appreciate your time and your participation in this discussion. This event will be recorded and will be available later on the California China Climate Institute website and our YouTube channel. So thank you all so much.